All right, folks, here we go. Again, I'm going to work through some of these problems. You're welcome to follow along with me or work on your own, but if you do choose to work on your own, I need you to be silent so that folks who are following along can focus. I'm actually going to go through all of these problems on number 1. You're going to see a section like this on the test, but it will be matching. So there'll be an answer bank that you'll match these up to. So what do we know here? Negative exponent means that we're going to flip the fraction. This is 2/1 right now. So an exponent of -1 just means flip the fraction. So that would give us 1/2. Right. We got another negative exponent. That means we need to flip our fraction, but this time there's an exponent of 3 with that negative. So let's start by flipping the fraction. 2/1 becomes 1/2. But this exponent of 3 here means that 2 needs to end up with a 3 on it. So that's 1/2 to the third. And we can go one more step with that because we know what 2 to the third is. What is 2 times 2 times 2? 2 times 2 is 4 times 2 is 8. So 1/8 would be our final answer there. Folks, if I get going too fast and you need me to slow down, please just get my attention. All right, anything to the 0 power is equal to 1. So 2 to the 0 is just 1. We've got a couple more problems with -1 exponents. Remember, -1 exponent just means flip the fraction. So 1/5 would become 5/1. I would simplify that to be just 5 though. (3/7) to the -1. -1 just flips the fraction, so 3/7 becomes 7/3. Here we've got a -2 exponent. The negative causes it to flip. That 2 is going to end up on both parts. So let's start by flipping the fraction. 3/4 becomes 4/3. And since there's a 2 there, we need to put that exponent of 2 on both the 4 and the 3. Let's clean this up. 4 squared. 4 times 4 is 16. 3 squared is 3 times 3. That's 9. So our final answer would be 16/9. Any questions on those first 6? All right, moving right along. Fraction exponents mean to do a root. So the 5 is going to be inside of a root. And whatever the bottom of your fraction, the denominator of your fraction is, that tells you the index that goes on your root. So since that's a 2, it's going to be a second root. Now, usually we don't write the 2 there if it's a second root. That's otherwise known as a square root. Usually we would leave that 2 out. You could answer either one of those, though. I would give it full credit either way. Usually this is how they would write it, but if you put the 2 on there, that's fine. If it's anything other than a 2, you've got to write that number in there, though. Okay, so when we get to part H, this is 1/3. That 3, that index of 3 needs to be on inside of our little crook in our radical there, because it's not 2. If it's a 2, you can leave it out. If it's anything other than 2, it's got to be in there. Here we've got 1/42, so we're going to do a 42nd root. So 42 goes inside the index there. All right, now if you have something other than 1 on the top of your fraction, that's going to stay inside of your radical. So this is going to be 5 squared inside of my root. The bottom of my fraction is 3, so that goes in the index. So that would be the third root of 5 squared. Let's simplify that. We know what 5 squared is. 5 squared is 25. So the third root of 25. All right, we got a 36. We're going to put a root on it. This is a second root. Do I need to write the 2 in there? Nope, I don't have to. Do y'all know what the square root of 36 is, though? We should probably simplify it if we can. The square root of 36 is 6. Last one in this section, we got 8. 1/3 power means we're going to have a third root. It's also called a cube root. And I know what the cube root of 8 is. What number can you multiply by itself 3 times to equal 8? 2 times 2 times 2 is 8. So the answer here would just be 2. In the next section, we're going to do the same thing just in reverse. So they're giving us all of the answers as roots here. We need to work backwards and figure out how can we write these as exponents. So they did not put a number in the index here. If there's no number written there, what do you assume is there? We assume it's a 2. So I didn't write this 2 in there, but we know there's a 2 there. So that's going to be 7 to the 1/2 power. 7 to the 1/2 power. In our second one here, they did put an index in here. So we know we're going to have a 1/3 for our exponent. So 7 to the 1/3 power. They gave us an index here also. This is a 5th root. So we're going to have a 1/5 power. This isn't even a number. It's an X. That's okay. 4th root's going to give us a 1/4 power. Now in part E, this has an exponent inside. So when I go to write my fraction, that 2 is going to go on top of the fraction. It's a 3rd root, so 3 goes on the bottom of the fraction. So x to the 2/3. Same idea here. The 8's going to go in our numerator of our fractional exponent. The 4 is going to go in the denominator. So x to the 8/4. And I think we can simplify that, can't we? Don't we know what 8/4 is? That's 2. So x to the 2nd power, x squared. All right, from here, I'm going to pick and choose some problems. I won't be going over every single one. I will be doing this again with my 6th period class. And when I do it with my 6th period class, I will try to do the ones that I don't do with you guys. Does that make sense? And I'll record that as well. So if you're looking for some help on this, if you're working on it, say tomorrow evening, just you can find the links to the videos on the Canvas. Let's see, why don't we go ahead and do the first one here. So we are doing we're going to try and analyze this exponential function. So I'm going to describe the function here either with a statement or a table or a graph. And then I want you to write an equation, figure out if it's increasing or decreasing, starting value, multiplier, all that fun stuff. So this first one's pretty straightforward because they tell you that the starting value is 400. They tell you that the multiplier is 0.5. The only thing that we really have to think about here is we have to know whether it's increasing or decreasing. And that depends on the multiplier. If you multiply by 0.5, are you going to end up with a bigger number or a smaller number than you started with? You'll end up with a smaller number. So this would be decreasing because we're multiplying by 0.5. Basically, if your multiplier is anything less than 1, then you'll be decreasing. Otherwise, you'll be increasing. And then we also need to know what the format of our equation looks like. Y equals starting value and then multiplier to the x power. So starting value was 400, multiplier 0.5, and we're finished with that one. So very straightforward. There's going to be one that will be similarly basic and simple on the test. However, I might give you a y-intercept instead of a starting value. I need you to know that the y-intercept is the same as the starting value. Okay, so I'm not going to actually finish this up, but the starting value of this would be 20 because the y-intercept is at 0, 20. Let's move on to the third one. We've got the table that goes 540, 320. So we can see really easily by looking at these numbers whether this is increasing or decreasing. These numbers are getting bigger, so it's increasing. The starting value is going to be the y-intercept or the y value when x is equal to 0. So in this case, that is 5. And the multiplier is the number that I would multiply to move forward 1 unit of x. So we need to think, what do I multiply a 5 by to get 40? Most of you can probably do that in your head. What if you weren't able to do that in your head, though? What would you put in your calculator to get an answer for that? We would do the second one divided by the first one. So we would do 40 divided by 5, which is 8. Most of you probably already knew that 5 times 8 was 40. That means our multiplier is 8. Once we have our multiplier and our starting value, it's really easy to write the equation. I'm going to skip the next one and go to the next page. Let's go ahead and look at the second graph on the next page, the one that's decreasing. So we can see that as we slide from left to right along this graph, that we would be going downhill, so that's decreasing. And with these ones where they give you the graph, my strategy, question? On this, I will get there eventually, yeah. Yep. I'll get your attention when we get to 18. My strategy when I have a graph is to find a couple of points and make a small table out of it. I'm more comfortable with tables than I am with graphs. So I'm going to look for a couple of points and make a table. This first point has an x coordinate of 0 and a y coordinate of 80. That 0 and that 80 tells me that my starting value is going to be 80. And then I have another point here. This one has a y coordinate of 1 and an x coordinate. It's really hard to read here, but that's a 20. So 1 and 20. And that should be enough for us to figure out what our multiplier is. I know that my multiplier is going to be less than 1. It's going to be 0 point something. What do I multiply 80 by to get 20? I know I would divide by 4, but we don't use division. We need a multiplier. So, so I might reach for my calculator and do what you just told me to do a second ago. Do the second one divided by first. 20 divided by 80 is 0.25. Is that correct? Is that what you guys are getting? Yes. Bless you. 0.25. And we'll just get those numbers into the equation. Right. Skipping the next one, we will do actually, let's see here. We need to do 2 more on this page. You guys want to do the two tougher ones? Let's do one kind of simple one and one tougher one. So let's do this one next. Can you tell me what the starting value is looking at those 2 points? Because of the 0, right? Because of that 0, the starting value would be 64. Can you tell me whether it's increasing or decreasing? It would be increasing. It's 0, 64, and then 3, 343. From 64 to 343, that's definitely increasing. Let's go ahead and make a table here. I need to go from starting at 0 and go up to 3. 0, 1, 2, 3, and I'll fill in the values that we know. And then all we're going to try and do here is get ourselves a multiplier. Okay, so our multiplier would be the thing that I would multiply 1, 2, 3 times to go from 64 to 343. I don't know what it is, so I'm going to call it B right now. B is what we've been using for our multiplier. So I know that I'm going to multiply B by itself 3 times. I'm going to go ahead and write that down. B multiplied by itself 3 times. And that has to get me from 64 to 343. So I need to figure out what would be my big multiplier to get from 64 to 343. So I'm going to grab my calculator. I'm going to do 343 divided by 64 to answer that question. That's a big old decimal. I'm going to write the whole thing down though. 5.359375. 5.359375. And then we'll solve that equation. That'll tell us what B is. B is our multiplier. So how do we get rid of an exponent of 3? Opposite of an exponent of 3 is a root of 3. I'm going to take a third root on both sides. Right now, could you please grab your calculator, type in the third root of 5.359375. Please try this right now. I will not be able to help you type in your calculator on the test. I need you to practice doing it now so you know how to do it. Every calculator is a little bit different. So if you've got your calculator with you, please type that in, make sure, and I'll type it in on mine and show you the answer you should be getting. You should be getting 1.75. If you need my help to know how to type that in your calculator, get my attention, please. More than happy to show you today. I can't show you on Thursday. Any questions? You guys all got it? You were able to put that in your calculator and get that answer? You're not going to try it? Just wing it, hope for the best on Thursday? You know how to do it? Okay. You've done it enough and you feel confident. That's good. All right, let's write our equation. Put that away, please. Don't just tuck it under your leg, stick it in your bag. Come on. Man. All right, let's do the last one on this page. Can you look at that and tell me what your starting value is? I can't. I can't because neither of these X values are 0. So I'm going to need to make a table and we're going to have to figure out what the starting value is. So let me make a table here. I always want to include 0. How far do I need to go up in the x's? It looks like I need to go up to 4. So 0, 1, 2, 3, 4. And I'll fill in my table based off of my numbers. In the 1 row, I'm going to have 6.25. In the 4 row, I'm going to have 0.05. So what can I tell by looking at this? I can tell it's decreasing. It's definitely decreasing, right? I don't have a starting value. I don't have a multiplier yet. Let's work on our multiplier first, because if we can find our multiplier, then we can work backwards to find our starting value. So there is some b value that I would have to multiply 1, 2, 3 times to go from 6.25 to 0.05. So b to the 3rd power, I would have to multiply by it 3 times, is going to be what? So let's figure out a big multiplier to get us from 6.25 to 0.05. So I'm going to grab my calculator. I'm going to do 0.05 divided by 6.25. And that gets me 0.008. And then we'll just solve this. I need to get rid of this power of 3, so we'll do a 3rd root on both sides. Again, make sure you're practicing typing this in your calculator. I'll tell you the answer you should get. If you're not getting this answer, get my attention so I can help you with that. B comes out to be 0.2. So we know that our multiplier is 0.2. So to go forward, we would multiply by 0.2. To go backwards, we would do the opposite. We would divide by 0.2. So let's take our 6.25, divide by 0.2. And that'll get us our 0th term, which is 31.25. Now we've got everything we need to write our equation. Y equals 31.25 times 0.2 to the x power, and we're done. Any questions from anything on that page? My big strategy is if they don't give me a table, I'm going to make my own table. Whether they give me a graph or a list of points, I'm going to put that information into a table because I'm more confident doing it in a table. There are other strategies to employ as well, but that's my preference. All right, moving right along. Number 4. I'm just going to do one of these 3 parts. Does anybody have a preference, A, B, or C for number 4? Was that a hand signal? I couldn't tell. Is that an A? A? Here we go. A, let's see here. Initial purchase price of $28.80. So that looks like a starting value to me. So when I write my equation, I'm going to go ahead and put $28,880 as my starting value. Then I just need a multiplier. Let's see if we can get a multiplier out of this. It says it depreciates by 13%. Does depreciate mean go up or down in value? Depreciate means it loses value. Appreciate means it goes up. Depreciate means down. So we're going down by 13%. Now, anytime we have an increase or decrease by a percentage, we have to start at 100. So I'm going to write 100, and this time, because I'm going down by 13, I'm going to go minus 13. 100% minus 13% is 87%. We'll turn that into a decimal, and that will become our multiplier. 80% is a decimal. You can move the decimal place or just take 87 divided by 100 in your calculator. You're going to get 0.87. So that's going to give us our multiplier for our equation, 0.87. They want us to say how much it's going to be worth in 5 years. I need to see your work for this. If folks who are working independently, could you look up here for just a minute? Make sure on the test when I ask you this question, I want to see that you've taken this equation and plugged 5 in for x. I want to see this right here. Don't just type it in your calculator and write an answer down. To get full credit, I need to see your work. Okay, so I would want to see this on your paper. Writing this down is going to be worth a point, and if you leave it off, you'll lose that point, even if you get the correct answer. Okay. And then I just need to type that in my calculator. So 5 years means I'm replacing the x with 5. So let's see what we get here. 28,880 times parentheses 0.87 to the 5th power is, we'll round that off to the nearest cent. $14,394.30. No, it'd be 40 cents if I rounded it up. When you're doing anything that involves an actual situation, you should always ask yourself the question, does that seem reasonable? We know the price of the truck is going down. This is a car, actually. We know that the price of the car is going down. If it started at 28,000, does it seem reasonable that it could end up at 14,000 after 5 years? Yeah, that seems reasonable. If I'd gotten an answer like 2 million, I might be thinking, no, that doesn't make sense. That a car would, if its price is going down, it can't start at 28,000 and go up to 2 million. All right, let's look at number 6. So this is also about a vehicle. And look at the information there. It said last year it was worth 43,000. This year it's worth 36,000. Is this truck appreciating or depreciating? Is its value going up or down? It's going down. So it is decreasing in value. So I think that I might like to make a table for this, because that's been my go-to strategy all along. We'll go X and Y. So 43,500, and then this year it's worth 36,100. Now we have a choice to make here, and we got a couple options. I just realized, did you guys realize that my numbers are out of order here? This is number 6 and the one after it is number 5. Whoopsie. Isn't that strange? Don't know how that happened. Here's our question though. Which one of these numbers is this year? It's the 36,100, isn't it? Usually the current value we use is an x of 0. So if I made this 0 for x right here, then what would I need to do for last year? I would do -1. Does that make sense to you that last year would be a -1? If this year is 0, if I were to go back in time, that would mean time is negative. So does that kind of make sense in your mind? It kind of seems weird to think of a year as being a negative, but since it's a previous year, then I'd say it does kind of make sense. Last year would be like -1. And then in a minute here, when we say 3 years ago, what do you suppose we're going to put in for x for 3 years ago? We'll put -3 in for x. Now you could have this be 0 and this be 1, but then this would get a little bit more complicated. You'd actually have to do -2 for this instead of -3. So I always try, if they tell me that this year is worth something, I usually make that x be 0. And then if it's a previous year, then I'll use a negative value for x. Okay, so we know that our starting value is 36,100. So when I write my equation, it's going to start off with 36,100. we're going to need a multiplier, which is what they ask us for in part A. So to find my multiplier, I'm just going to do 36,100 divided by 43,500. It's still the second one divided by first. So let me type that in my calculator and see what I get. So I'm getting that. I'm going to go ahead and just round it off to 2 decimal places. That would be about 0.83. So there I've got my multiplier for my equation. This to me is the tricky question. What is my percent decrease? Remember, when we do percent increase or decrease, we always start with 100 and we add or subtract. That's a decrease, so we would subtract something. 100 minus something gets us to, what is this as a percent? 0.83 is the same as what percent? 0.83 would be 83%. So what would I need to subtract from 100 to get 83? 100 minus something is 83. What is that something? 17. So this would be a 17% decrease. Because 0.83 is, well, that's 83%, and that's 17 less than 100. For part D, again, make sure on the test that you show your work for this. I'm going to take this equation, I'm going to put -3 in because it was 3 years ago. We're using a negative value for X. So make sure you write down what you're typing into your calculator, then type it into your calculator, and then write down your final answer. So 61,300 or 135. Sorry, $63,135 and about 40 cents. Does that make sense? If it was worth 36,000 this year, does it make sense it was worth more 3 years ago? Yeah, because the price is going down. So it should be more. If I go back in time, then the price should go up as I go backwards in time. It's also asking how much is it going to be worth 3 years from now? What am I going to put in for X if we're going 3 years into the future instead of past? Put a +3 in. So 36,100, that's the price now. 0.83, this time to the +3rd power. Gets me $20,641.51. Let me move this up a little bit. That's $20,641.51. So again, big strategy here was to create a table. We're going to skip number 5 and move on to, was it number 8 that you were asking about? 18, okay. So we'll get there, I promise. We're moving on to the second number 6. So this is going back to chapter 5 with our arithmetic geometric sequences. Let's just take some notes here. I'm not going to do this first problem, but what's the key to arithmetic? What are we looking for a sequence to be arithmetic? Is an arithmetic sequence a sequence where we're adding or subtracting the same thing, or is it a sequence where we're multiplying by the same thing each time? Adding. So arithmetic sequence is one where you're adding or subtracting the same thing each time. Geometric sequence is one where you're multiplying by the same thing each time. So for example, in, let's see here, in part C, it looks like I think I'm adding the same thing here. I'm doing plus 11 each time. Yeah, it's plus 11. So C would be arithmetic. All right, moving on to number 7. Which one you guys want, part A or part B? A? All right, so we're going to write the first 5 terms. 1, 2, 3, 4, 5. And to do this, we're just going to plug some values in for n. The first term has an n value of 1. Thank you. Gotcha. First term has an n value of 1. Second term has an n value of 2. And so on and so forth. So I just need to take this equation and plug 1 into it and write down that number. So -4 times 1 is -4 plus 12, that's 8. Feel free to use your calculator if that makes it easier for you. You go ahead. For 2, -4 times 2 is -8. -8 plus 12 is 4. For 3, -4 times 3 is -12. -12 plus 12 is 0. There is a bit of a shortcut though, yes? Yeah, passes there. There is a bit of a shortcut. Once you figure out the first one, if you know what you're doing with these equations, you should be able to look at this and say, ooh, that's an arithmetic equation, and my sequence is going to be subtracting 4 each time. So you're welcome to use that as well. You could have just figured out that the first term was 8. Now, why is the first term not 12? 12 is not the first term. What term is 12? 12 is the 0th term, right? So we didn't use 12 here because they said the first 5 terms, the first term, second term, third term. So we did need to plug it into the equation to figure out that the first term was 8. But after that, we could just go -4, -4, minus another 4 would get us to -4, minus another 4 would get us to -8. And there's our first 5 terms. So when you go to do part B, you're going to do the same thing. You're just going to be plugging 1, 2, 3, 4, 5 into this equation instead. And you'll probably want your calculator for this because these get pretty big numbers. All right, let's look at number 8. Let's see here. Let's start with part C. Now, when I look at these numbers, when you look at these numbers, are you thinking arithmetic or geometric? I'm kind of thinking because these aren't very far apart, but like these are much further apart, and these are even further apart. I'm thinking it's going to be geometric. I don't think there's something I can add to go forward. So I'm thinking probably it's going to be geometric. So my equation is going to look like this. That looks an awful lot like an exponential equation, doesn't it? Just with t's and n's instead of x's and y's. We need a multiplier. Anybody happen to know what you multiply 1.5 by to get 4.5? If you don't know, we could type it in our calculator. We do 4.5 divided by 1.5 to get 3. So our multiplier is 3. And then we need our 0th term, our starting value, which would have an n of 0. They didn't give us that, but we can work backwards and figure it out. We'll divide by our multiplier to go backwards. So 1.5 divided by 3 gives you 0.5. So 0.5 would be the starting value. Let's also look at E. Same idea, but it's not in a table, it's a list. Remember, we're going to need our 0th term, which they didn't give us. So I'll go ahead and give myself a space for that. When I look at these numbers are all pretty close together. I bet this one's going to be an arithmetic sequence. I bet there's something that I can add to move forward through this sequence, and it looks like it's 4 plus 4 plus 4 plus 4. That should make it pretty easy for us to move backwards to figure out the 0th term. We'll go minus 4 to go backwards. 20 minus 4 is 16. Arithmetic sequences have equations that look like this. We're adding 4 each time. That would go in front of the n. Our 0th term starting value is 16. That goes at the end. How many of you have taken the time to put an example of an arithmetic and a geometric sequence into your blue chapter 7 packets? Has anybody done that yet? Good for you. I'm seeing some people nod their heads yes. It's not something that we did together. The blue packet has exponential stuff in it, but it would be a good idea to have that in there just in case you get to this part of the test and you're like, oh man, I can't remember how to do that. That was like a month and a half ago. So I'm glad to see that several of you have already thought ahead and you're like, yeah, that would be good information for me to have. If you have not done that yet, make yourself a note that sometime before Wednesday, it would be a really good, smart idea to pick a couple problems. You could pick a couple problems right off of this practice test if you'd like, and put them into your blue packet so that you know what a geometric sequence equation looks like, and you know what an arithmetic sequence equation looks like. Okay, moving on to the next page. We're going to graph and find a solution here. I'm going to go ahead and do number 10 because number 10 is a little tricky. Wait for the pass to come back, please. Shouldn't be too long. First equation is straightforward. The second equation is going to take some work. Let's go ahead and graph the first equation. It's got a slope of -1/4. So the slope should be going downhill. And if I make my slope triangle, it's going to go, sorry. If I make my slope triangle, it should go down 1 and over 4. And my starting value, or my y-intercept, is going to be 2. So on the y-axis, I'll draw a point at 2. And then I'll do my slope. I'll count down 1 and over 4. So down 1 over 1, 2, 3, 4. Draw a point. Down 1 over 1, 2, 3, 4. Draw a point. And I'll back it up and go the opposite direction. Up 1 and over 4. Up 1 and over 4. And do I have a ruler here? I do. Now the second equation is not in the correct form for us to just be able to look at it and find the slope like we did in the first equation. So I'm going to copy this second equation over to the side where I have some room to work on it. X plus 4y equals -4. And my goal is going to be to try and get this y here by itself. We're going to isolate it. So I need to start by getting rid of the x and the 4 here. So I'm going to start by getting rid of this x. I'm going to go -1x on this side and -1x over here. Those will cancel. I've got 4y's left over. These can't combine, so I'll just put them both down here. So -1x and a -4. We almost got this y by itself here. We've got this 4 that's multiplying by it, so we need to get rid of that through division. We'll divide everything in the equation by 4. And then we'll have a y equals equation that we can graph. So y equals, we've got -1/4 x, and then 4 over 4 is 1. go ahead and graph that. All right, this has the same slope. It's also a negative slope. It's going to go down 1/4. This time we're starting at -1 though. Down 1/4, down 1/4, up 1/4, up 1/4, and we'll draw our line. Now, our overall goal is to find where these two lines intersect. Are they ever going to cross each other? Nope. Okay, so that must mean our solution is no solution. The reason is they don't intersect. All right, let's tackle a couple systems problems. Well, that was a systems problem. We were doing that graphically. Let's do some algebraic systems problems. We'll do one of each flavor. So we need a equal values. We need a substitution and an elimination. 11, 12, 13, 14. Which one of these is a equal values problem? Of those four problems, which one would you use equal values to solve? Lucky number 13. Yeah, that's the one that's got y equals for both equations. Let's tackle that one first. Equal values, we just take the thing that y is equal to in each equation and create an equation out of it. So -7x minus 15 and 6x plus 12, or plus 11 rather. Throw an equal sign in between there. They're both equal to y, so they should be equal to each other. And then we'll solve this. I need to get x by itself. I've got x's on both sides though, so let's get rid of, I will choose to get rid of the -7x. So I'll go plus 7x on both sides. That's going to cancel, leave us with a -15. Over here, I've got 13x plus 11. And I'm going to work to get this x by itself. Let's get rid of this plus 11 first. We'll do -11 on both sides. -15 minus 11 is -26. And we'll divide on both sides by 13. And we should be home free at that point. 26 divided by 13 is 2. That's going to be a -2 though. So x is -2. We are halfway to our solution, but we've done most of the work. We still need to find y. So we're going to go back to our original equations, pick one, we'll put -2 in for x, and then we'll be able to figure out what y is. In my opinion, this second one looks a little bit simpler, so I'm going to go with that. Y equals 6x plus 11. I left the x out because I now know that x is -2. Six times -2 is -12. -12 plus 11 is -1. So my final answer, the solution is -2 for x, -1 for y. Stick that inside a point and we're done. Yes. No. but I will get to 18. We're almost there. I appreciate your patience. All right, we want to do one that's substitution. Look through those 4 problems and tell me which one looks like a good substitution problem. 11 looks like a good substitution problem. Yeah, it's got one equation that says y equals, but the other equation is not. So substitution, we're going to take this thing that y is equal to. We're going to put it parentheses around it. We'll put it into the other equation in place of the y. So let's copy down this second equation. We're going to leave the y out though. We'll leave a big old set of parentheses in its place. So 5x plus 8, and then the y would come next. I'm leaving a blank parentheses there, and then equals 4. Inside of that parentheses, we'll go ahead and put negative 6x plus 22, because that's what y was equal to. All right, 5x. What's that? Oh, nothing. This was, we had talked about this type of problem before, and I was like, let's go over this, but you fixed that. You figured that one out. All right, 8 times negative 6 is negative 48. 8 times 22 is, I better use my calculator. I want to say 176, but it is 176. Those are some big numbers. It's all right, we got this. Let's solve that. I got a couple x's in there. They're both on the same side, so we'll go ahead and combine them together. 5x and negative 48. 5 minus 48 is negative 43. Thank you. And now we're ready to start solving. I think I would probably get rid of the 176 first. Negative 43x equals 4 minus 176 would be negative 172. And then we'll divide both sides by 43. I really hope that 43 goes into 172. It does 4 times. X equals 4. Are we done? Nope, we still got to find y. We'll take that 4 and plug it back into this equation here. So that equation is y equals negative 6x plus 22. Plug in the 4 in there. Negative 6 times 4 is negative 24. Negative 24 plus 22 is negative 2. So final answer 4 comma negative 2. And all we have left to do now is an elimination problem. And we're going to go ahead and flip over on the back and do number, oh no, 18. Where'd she go? Terrible timing. Will you make sure you take good notes? Charlie, will you make sure you take good notes? We're going to go over number 18 here so that you can catch Nara up. She's been waiting for this one. Thank you. All right, let's look at 18 together. I could try and stall for a minute, but I don't want to do that. All right, coffee stand near a high school. That sounds familiar. I feel like we've got one of those around here. Does this seem like reasonable prices? $4.25 for a small drink, $5.75 for a large drink. Is that cheap or is that expensive? What do you guys think? I don't go to mug shots that often. Reasonable? You guys don't go to mug shots either? That's a pretty reasonable. Okay. So one day at lunch, they sold 55 drinks for a total of $298.25. We want to figure out how many of each they sold. So we're going to end up writing 2 equations. we need to have a couple variables. Would you guys like to use X and Y, or do you want to use some different variables? X and Y? Okay, let's do X and Y. And I can tell that we're going to have like two things adding up because we've got small drinks and large drinks adding up to total number of drinks and then prices for these two also. So I know from experience that when I write my system of equation, it's going to be something X plus something Y equals something for at least one of my equations. Now, we should probably be very clear about what X and Y are going to represent. We're doing number 18 right now. Perfect timing. So the types of drinks we have are small and large. Do you want X to be small and Y to be large? Does that work for you guys? Okay. So I'm just going to go ahead and label this so I don't forget later on. So small drinks and large drinks. So if you were going to multiply X by something, what number seems like you would be multiplying by the number of small drinks? 425 is how much each one of them costs, right? So if X is the number of small drinks, let's say it's 20 small drinks. If you wanted to figure out price for that, you would go 20 times that cost. That makes sense. Let's put 4.25 in front of the X. And follow that same logic and tell me what you're going to put in front of the Y. 5.75. Now we got to figure out what number is going to go over here. We have two choices. It's either going to be the 55 or the $298.25. Which one would you guess? The 55 or this one? You think this one? What makes you think the $298? It's right. You're right. It is this. Is this 425 and that 575? Is that also money? This is money, isn't it? Wouldn't it make sense for this to be money also? Total amount of money. So 298.25 goes here. All right, we need two equations though. So this was the total amount of sales. In total, they sold 55 drinks. I need an equation where we have some stuff adding up to 55. What do you think? Yeah, it would be. It would just be X plus Y, right? X is the number of small drinks and Y is the number of large drinks. Doesn't it make sense if you add those two things up, you're going to get 55? 55 is the total number of drinks that they sold. So the second one is just X plus Y equals 55. All right, let's solve this. I'm going to copy these down here. 4.25x plus 5.75y equals 298.25, and then we've just got 1x plus 1y equals 55. So this looks like an elimination problem. We haven't done one of those yet, but this will give us a chance to practice that. I think I could multiply the bottom equation by something to eliminate either the x's or the y's. Do you want to eliminate the x's or the y's? What do you guys want to eliminate? The x's? All right. What do I need to multiply this bottom equation by so that when we add, it goes away? We're going to multiply it by negative 4.25. That's everything in the equation gets multiplied by negative 4.25. So top equation stays the same. Bottom equation. So negative 4.25 times x is negative 4.25x. Negative 4.25 times y is negative 4.25y. Negative 4.25 times 55, I have no idea. Negative 233.75, is that what you got? Heck yeah, that's definitely going to eliminate these x's. Those are gone. What's here? 575 minus 425. I think that's 150. That's 1.5y equals 298.25 minus 233.75 is 64.5. A nice simple equation there. We can solve this really quickly. We'll just divide both sides by 1.5. We'll get y equals, drum roll please, 43. Oh no, we still got to find x. Oh, that'll be easy though, right? How many total drinks? 55 total drinks. So 43 of them were larges. How many did that leave left over for smalls? What's 55 minus 43? 12. So 12 small drinks. And 43 large drinks. Okay. And that's all we got time for today. Are we all clear on what is due next class? You are going to turn in this practice test. I'll give you points for completing it. And then our final assignment is the Chapter 7 closure. Don't forget you got answers in your textbook at the end of the closure section, so make sure you're checking your answers. If you've got questions for me, I will be in the classroom by about 7:25 or so on Thursday. So come on in a little bit early if you've got questions over anything. Feel free to email me as well. If you're working on it tonight and you email me, I can get you a response tomorrow during school. If you wait until Wednesday night to start working on your stuff and you email me, I may not be able to get back to you. All right, you do not have to turn in your practice test today. I would recommend you hang on to them and use them as an opportunity to study. They're due on Thursday. If you absolutely want to turn them in today, you can, but you do not have to.